What is CAN? CAN is a method of communication between the electronic devices embedded in vehicles such as engine management system, active suspension, central locking, airbags, and air conditioning. What are the types of CAN frames? There are four types of CAN frames. One is data frame, which carries actual data. Second one is remote frame, which requests the data from another node. Error frame occurs when a node detects an error. Overload frame provides extra delay between the frames. What are the layers of CAN? There are three layers in CAN. First one is physical layer, voltages, wiring, and signaling related. Second one is data link layer, which relates to arbitration, frame format, error handling. The last one is application layer, which relates to ISO, TP, UDS, CAN open. What are the types of CAN frame format? There are two types of CAN frame format. One is standard CAN with 11-bit identifier. Another one is extended CAN with 29-bit identifier. What are the types of CAN error? There are five types of CAN error. First one is bit error. A transmitting node reads a different bit on the bus than what it sent. Example, if you send a dominant bit 0, but it reads as this is bit 1. Stuff error. CAN uses bit stuffing after 5 consecutive bits of the same polarity. An opposite bit is inserted. If the rule is violated, a stuff error occurs. Cyclic redundancy check error. Each frame has a cyclic redundancy check field. If the receiver calculated cyclic redundancy doesn't match the transmitted cyclic redundancy check, then it tries a flag called cyclic redundancy check error. Form error. Fixed format fields. Example, cyclic redundancy check delimiter, acknowledge delimiter, end of frame must always contain recessive bits. If a dominant bit appears where only recessive is allowed, form error occurs. Next, the last one is acknowledge error. The transmitter expects at least one receiver to send a dominant acknowledge bit. If no node acknowledges, acknowledge slot remains recessive and acknowledge error occurs. How CAN works? CAN works on the basis of carrier sense multiple access with collision detection and arbitration on message priority. It is also abbreviated as CSMA/CD plus arbitration. Therefore, each node on a bus must wait for a prescribed period of inactivity before attempting to send a message. What are the 7 fields of CAN data frame? The first one is data frame, second one is arbitration, third one is control, fourth is data, fifth is cyclic redundancy check, and sixth one is acknowledge, and this end of frame. What are the uses of CAN? CAN is used in the development, testing, and analysis of individual ECUs. Its uses are communication between the automotive ECUs, infotainment and steering wheel controls, vehicle safety and body electronics, industrial automations, diagnostics and firmware updates, marine and aerospace communication. What are the characteristics of CAN? The characteristics of CAN are: it's a message-oriented communication, multi-master network, non-destructive arbitration, built-in error detection and handling, deterministic and real-time, robust and noise immune, flexible and scalable, and it is a low wiring cost. What are the bit fields of CAN? There are almost 11 bit fields of CAN. The first one is startup frame, which consists of one bit. It marks the beginning of a frame and allows dominant 0. Next field is arbitration field, which consists of 12 bits. 11-bit identifier message priority. Lower ID is equal to higher priority. Next one is RTR, remote transmission request. It consists of one bit. Dominant is 0 data frame, whereas recessive is 1 remote frame. Next field is control field. It consists of 6 bits. IDE, identifier extension bit, 1 bit. 0 for standard frame. RO reserved 1 bit. Next one is DLC, data length code, which consists of 4 bits, which specifies the number of data bytes from 0 to 8 bits. Next one is data feed, which consists of 0 to 8 bytes, which contains the actual payload 0 to 8 bytes in classical CAN. Next one is cyclic redundancy check, which consists of 6 bits cyclic redundancy check for error detection, which includes cyclic redundancy check sequence 15 bits plus cyclic redundancy check delimiter of 1 bit. Acknowledge field, which consists of 2 bits. Acknowledge slot 1 bit. Any receiving node pulls dominant to acknowledge receipt. Acknowledge delimiter 1 bit. Recessive bit. Next, end of frame, which consists of 7 bits, marks the end of the frame. All bits are recessive here. And the last one is intermission or interframe space, which consists of 3 recessive bits separating 2 frames. That's all for today, guys. Thank you, and please hit the subscribe button if you want more videos related to technologies. Thank you. Have a great day.